Hello, my name is Arthur, and in the last video we modeled up this simple vehicle, and the intention is to get this into a new Godot project with in an RTS direction, so a click-to-move vehicle based on a rigid body. So I'm going to try to make this into a simple rigid body type of vehicle. First thing I'm going to want to do before I export it is give an animation to the wheels. So let's just select the wheels and get this out of the way. And we'll need to be in layout so we can see things. Let's make the animation from frame 0 to frame 17. I think that's what was done with the tank wheels. And we'll get to that side view again. And we'll just set in some keyframes. So we'll insert a rotation keyframe at 0. Insert rotation. We'll come up to frame 17. We'll rotate that 360 degrees. Whoops. We'll need to go into individual origins to rotate the wheels individually. Rotate 360. We'll insert a rotation keyframe here. And then we'll change the interpolation mode to linear because Bezier won't work for wheels. And that should work fine. In Blender, it'll have a stutter. But in Godot, that stutter won't exist. So now to get it into Godot, we need to go into nonlinear animation, and push each of these actions down and give them the same name. So we'll want to change NLA track to drive. And we'll just copy that, Control C and Control V to paste it in each of these ones. And that should come through in Godot as one animation. So we'll return to the 3D viewport. That's all set up and ready to be exported. So in Godot, I've started a new project and I've given a couple of folders. So one for the map with an import folder inside of it, and one for this vehicle. I'm just going to call it Vehicle 1, and an import folder inside of that folder. That way I can sort of keep my imports and my project a little more organized than the last project folder, which was all experiment, and this is an experiment too. So we'll export the vehicle. We'll export. We're going to go GLTF again. That's why we did nonlinear animations. Navigate to the folder and into the import folder and just export. Now I'm going to want my map, so we're going to use the map I did in 2 videos ago where I discussed map and assets. So I'm going to copy my Jeep and open an instance of Blender and open up that blend with the map in it. So this map is entirely experimental also. Everything is always experimental with me. So we're going to delete the tank out of this, and we'll come back to the tank. If this is working out as a rigid body vehicle, we'll look at making the tank into a rigid body vehicle in the same project. We'll paste in the Jeep. It's going to be big because the Jeep is approximately 4 times larger than the tank. So we'll just move that somewhere that we can see, and we'll select everything else. We'll want to be in median point, and we're just going to scale it. So S4, and see if the vehicle fits inside of that scale. So if it's about right on top of the road, I would say that's pretty reasonable. So let's drop down all of the parts of the vehicle so we can select them all. And we'll delete the vehicle because it doesn't need to be in the map. We're just going to delete the map as is. It's not a complete map, but it'll work for a test floor for the project. So we'll export that. And in the future, when I do more to the map, I can just overwrite this map. So I'll navigate to that folder, into the import folder for the map. I'll give it a matching name for the folder, so map1, and export that. And I can just close down Blender. I won't need to save these. I can remember that the scale of the map was 4 times for this. And then for the Blender file, I guess I'll save the animation. Shouldn't make much difference. So that gets us the map imported there and the vehicle imported here. Let's change the spatial into RigidBody. So we'll re-import that as a RigidBody. And we'll open up the vehicle and have a look at what we got there. So that all looks good. We'll check the animation. So that needs to loop. The animation looks good, so we can stop that. We'll wind that back to 0. And let's disappear the animation player. So the vehicle will need some collision shapes. Let's start with the vehicle's main body. That will be easy. So we'll give it a collision shape. That is a new box shape. And we'll just center that and make it something like this. And it doesn't need to be perfect. Because we're still in testing here. So if the collision shape needs to be refined, that can be done later. Now I'm going to give collision shapes to the wheels, except they're not going to stay part of the wheels. They're going to get moved out. So it's part of the collision shape of the rigid body. But we can use the location of the wheels to get them in the right place. So we'll add collision shapes to that. We'll make them cylinders because we're going to make them the shape and size of the wheel. They'll need to be rotated on Z by 90 degrees so that the cylinder is facing the right way for the wheel. They need to be scaled in and down to be about the size of the wheel. And I already know the dimensions, so we're going to go to entering them as text. To fit the wheels will be a radius of 0.25 and a height of 0.2. And that will fit the wheels quite nicely. So that's the collision shape on the wheel. We'll repeat that for each one. So we'll give it a collision shape, a cylinder shape, 0.25. And 0.2. We'll rotate that 90 degrees on Z. Do the next one. Collision shape, cylinder, 0.25 and 0.2. And to find the values, I just sized them the first time around and kind of rounded them off to easy to remember numbers. So that gets that one in, and we'll do this one, add a collision shape, cylinder, Enter in our values, 0.2, rotate it so that it's the right way around. Now we can take these collision shapes and reparent them, and they'll just hold the position of the wheel, so they'll be in the right place to represent the wheel. So that's most of the basic setup. We're going to leave the camera off of the vehicle for now, but later on I'm going to put the camera onto the vehicles because that's part of the experiment for this project, is trying an RTS where the player can only see from the point of view of the units. So later on we'll get the camera onto the vehicle. For now we can save this scene, so we'll save scene as. We'll go up a directory so that it's not in the same folder as the import. And hopefully that will help me have some better organization than in the last project, because the organization in that project was horrible. So we'll just re-import the map to open it up. On the map, we'll take the ground and we'll make it a tri-mesh static body. We don't have much for hills here, but we do have a slope on the road, and that'll give us an idea for how the vehicle's behaving when it comes down a slope and stuff. So with that done, we can basically just save this scene and add in a camera later. So again, we'll go up one. We'll call it map 1 scene and save that, and we can collapse the import and come back to the vehicle. So the vehicle needs a script. So we're going to add a script. Let's see, template, we'll do no comments. And that's going where we want it to. So that all looks good. We'll go variable speed equals 3. Variable turn speed equals, we're just going to set this at 1. It'll probably actually be beneath 1. Variable direction equals vector 3. Now, because we're dealing with RigidBody, we're not going to have a function physics process. What we'll do is we'll have function, let's check the documentation so I can remember. So it's integrate forces is the function. That's most appropriate for the things we're doing with a rigid body. So we'll function integrate forces, and that will be right here. So we're going to aim towards click to move, but the first thing to do is to just get the vehicle moving to figure out how to get it moving. So we'll start off with a variable engine force. And that will equal input dot get action strength UI, I think down. And these are reversed because we're going along a minus Z. So engine force minus equals input dot get action strength UI up, and then a variable steering equals input dot get action strength UI left. And hopefully none of these are reversed. Not a big deal if they are though. Minus equals input dot get action strength. Oops. UI right. And that's spelt wrong. So that gets us our input, so our arrow keys here to just get the thing moving. Now we would be state dot angular velocity equals, angular velocity dot y equals steering times turn speed. And turn speed has no effect right now, but we might want to slow down the steering. And then direction equals transform dot basis dot z times engine force times speed, and state dot linear velocity equals direction. And that's enough to get us moving. Now we're going to go with default gravity, even though default gravity is slow. So we can save our vehicle, come into map, we'll bring vehicle on in here, and let's pull that out and pull it up. And we'll pull it up a little bit so the camera can see that it's falling slowly. And we'll add in a camera to the map. So add in camera. And yeah, I have all these things found in advance. We'll pull that out to the outside of the road, pull it back, pull it up. That should be enough to be able to see what's going on, and hopefully everything's working here. So we can see the vehicle dropped pretty slow to the road, but it's not showing any of the tendencies of the rigid body vehicle node. It's tipping a little bit. That was a little strange there. I'm not sure what happened there. It's tipping a little bit strange on the slope because it has no suspension. And that's kind of just going to be the way it is. We don't have the animation playing or anything, and currently it can turn while it's standing still. But that's because we're just gotten it moving with direction keys to see how it functions. And it seems to be functioning okay, really. And a little bit of tweaking on the speed and the turn speed, and giving it the script to be a vehicle that moves to a click to destination will change the way that it appears when it's moving, because it'll never have the opportunity to do this. That won't be part of its movement. It'll always have a forward motion in order to be turning. So having this kind of control over it isn't going to exist, and reverse won't exist either. That's just not part of a point-to-click movement. But it'll be able to turn to its destinations and stuff. And maybe that's a little bit less than perfect, but that's okay because we're going for simple here. And it's able to tip and adjust for coming off of that hill. It doesn't need a special function to align itself with the floor. So I can be satisfied with the way that that's working. I think there's other benefits as well. And one of the complications you can run into with a click to move type of movement in is sending vehicles to the same destination, in where kinematic bodies will endlessly fight to get to that one single destination, whereas rigid bodies will push each other out of the way. So it has a different dynamic than kinematic bodies and may actually relieve some complications that can arise from kinematic bodies. So that's about it for this video. I've opened up some of the scripts from the previous set of videos dealing with the tank, and it's entirely likely the tank is going to end up in here. So what I have is the world script, and this deals with the click to movement, so being able to select units and give a place on the map, place flags on the map to be able to give a unit paths. Now some of this is going to be different in this effort because I have a different idea. And then I have the unit script here in my text editor to be able to take what I need out of it to get the vehicle functioning as a click to move vehicle. So the differences will be there will be no physics process delta, so that would be changed. We don't need to store gravity because the rigid body's going to handle the gravity. We'll probably change get direction to get rotation, but otherwise that will function the same. And the vehicle will need to have a compass like the old like the previous tank did. And yeah, a lot of these things are actually quite similar. Instead of velocity, we would be linear velocity to get our forward motion. Our rotation degrees will be angular velocity equals get rotation with the compass and the destination. So a lot of this will function the same. We'll build in the damage, the chute, the HUD and stuff like that. But we'll pretty much be taking out the navigation, so the flags, the selected function, so the vehicle will need a mesh to show that it's selected. I'm not sure that this is going to function the same way though. That might actually come down to a need to add in an early HUD and be able to select units from the on-screen display by click of the mouse. Because for the vehicles to have a camera, selecting vehicles through the camera might not be the way to go. It might be more select vehicles from the menu and either have a camera on the vehicle or have the camera fly to the vehicle. And there's merit in both ideas. The fly to the vehicle would be kind of cheating the idea though. So yeah, I haven't worked out any of those details. Things like, should the camera on the vehicle rotate? And I didn't actually give the hatch that should be in the top of this vehicle for the gunner. But the idea is the camera would kind of represent a person in that hatch. So it would be able to see around the vehicle, I think would be reasonable. And that way, the only view the player gets is from the perspective of different units. So that's kind of the concept. It's just a concept. I haven't tried it out at all, so will be part of part of the different experiments in here, like the map is an experiment, the vehicle is an experiment, and the concept is an experiment too. So in the next video, we'll start getting that experiment working. So we'll look at getting a camera onto the one unit and getting his navigation set with point to destinations. So it'll be a point to his destination to move him around and see how that works out. And until then, I hope this video was helpful. Take care.